Good morning, class, and happy Purple Thursday. Sorry I'm not in class today. I got pulled out for a meeting. But we're going to start with the notes that you see in front of you. Hopefully you found them in the Learning Center. And we're going to kind of go through a little review at the top and get into something new as we get into this new unit, which is called factoring. We'll talk more about the new unit in class tomorrow. But let's just hit the notes running and see if we can make this video not terribly long. We're going to do just one page, and the rest is going to be for homework for you. The first section deals with a concept called greatest common factor, and I hope that is review for you. We will give you a quick recap in just a second, but I think that you've done these problems before, so hopefully we don't need to spend too long on there. Greatest common factor is exactly what it sounds like. It's the largest or greatest common thing they have in common. That's a factor. And the factor is that word you might not remember. A factor is a number that goes into another number evenly. That's the informal definition. We'll look at the formal definition in class tomorrow as well. But basically, what goes into 5 and 30 evenly for number 1? And what's the greatest of those numbers? Now, 5 only has two factors, 1 and 5. And 30, 5 also goes into. It has a lot more factors than that. So we could, if we want to, we could list out all the factors of each. I'm not going to do this every time, don't worry. 30s goes 1, 2, 3, 5, 6, 10, and so the pink ones are all the factors of 5, the green ones are all the factors of 30, and the greatest one that they both have in common is, of course, the 5. So they need to have it in common, and what's the biggest one they all have in common? If they have nothing in common, then it's going to go revert back to 1, but 5 is the answer for the first one. You can have a multiplication chart. That's a helpful tool to use on these if you have one, or just trying with your calculator. 48 and 88. I know that 6 times 8 is 48, and I'm kind of curious if each of those go into 88. Turns out 8 does go into both of those. I'm pretty sure that's the greatest common factor. Again, we can go quickly through these, and we can break them down as much as you want to if you have questions on them. 20, 50, 70, those all end in 0, so I know 10 goes into all of those. And my other question would be something like 20. Does 20 go into each one? Nope. So it is 10. Last one's definitely a tricky one. I looked at these numbers for quite a while, and I was trying to remind myself like what the 3's trick is. I know 66 is divisible by 3, but are these other numbers divisible by 3? If you don't remember the 3's trick, it's if you add up the digits, like 1 plus 4 plus 3, that's 4, 5, 6, 7, 8. Is 8 divisible by 3? No, it's not. So this number is not, 143 is not divisible by 3. So what the heck numbers do go into here? I had to consult my multiplication chart for this one. 143 was the one I didn't know, so I started with that one. 1, 11, 13, and 143. Those are the only things that go into 143. When I test that against the others, 11 actually goes into all of them. So that's a little bit of my thought process when I encounter a trickier problem like that. There are lots of tests. You know some of them. If it's even, it ends in 2, 4, 6, 8, 0. If the digits add up to a multiple of 3, then it is a multiple of 3. Same thing with 6. There's a couple other tricks we can talk about as well, and maybe you know some. But today we're actually talking about greatest common factor, not just of constants, but also of monomials. So let's start with the constants. The greatest common factor, GCF, is the largest factor. So we just defined it above, but now we're defining it in words. The largest factor shared between 2 or more numbers. And these examples, 5 and 6, ask you to kind of go in the other direction from the first warm-up problems. What 2 numbers have a greatest common factor of 7? There's lots of possible answers here. I'm just thinking of numbers that 7 is a factor of, like 14, 7, 21, and I'm going to pick 2 of them, like 14 and 21. And you just have to be careful. Like, I could not have picked 28 there, because then 14 would have been the greatest common factor. So just be careful you don't double one by accident, or create something that has a larger common factor by accident. 2 numbers that have a greatest common factor of 11. How about 11 itself? And, I don't know, 44. If you do pick one of the numbers to be your greatest common factor, then you're assured that it's at least the largest, because you can't go higher than 11 for factors of 11. So that's all greatest common factor review. The new part today is getting into greatest common factor of monomials. Monomials, again, is just a fancy way of saying a term. You can see examples in the example there. 15x squared is a monomial. And the process here is just the main idea that our greatest common factor is not just going to be a number, but it's also going to include variables. So in monomials, a greatest common factor can include variables. And it's a simple process. Again, if you think about that first example there before we fill in the rest of the notes, 15x squared. 15 and x squared are both factors of that. Like, it's all multiplication. So our process for finding the greatest common factor is to find the greatest common factor of the coefficients and then find the greatest common factor of the variables. Now, finding the greatest common factor of the coefficients, that's what we were just doing. There's nothing different about that. I think you know how to do that. The thing that's new is finding the greatest common factor of the variables. So if it's going to be a common factor, obviously it has to be a variable that appears in all of the terms. If it was 15x and 3y, those aren't the same letter, so they can't be a common factor. And then with the exponents, let's take a look at the first example. 15x squared and 10x squared, 10x to the third power. Each of those has at least two x's in them, because this is really 15 times x times x times x, and this is really 10, I did that wrong, 15 times x, and that's really 10 times x times x times x. So they share two of the x's. And so because they share two x's, x squared is a common factor. If you think about it in another way, x squared is part of the first number, and if I multiply x squared times another x, I would get x to the third, so x squared is also a factor of x to the third. So, filling in the rest of this, use the lowest exponent, or smallest, use the lowest or smallest exponent that appears on that variable. So because I had an x squared and x to the third, that's why I went with x squared. And with the coefficients 15 and 10, the greatest common factor is 5, so my greatest common factor is 5x squared. And let's quickly look at example number 2. We're almost done with these notes. Greatest common factor of 2 and 14 is just 2. And it looks like they each have an x. That's an x to the 2, that's an x to the 1. The lowest exponent is a 1, so my greatest common factor will just be x to the first power. They each have a y in them, so that can be a greatest common factor too. The smallest exponent is a squared on the y, the other one's a fifth. And this first term has a z, the other one does not, so that is not part of the greatest common factor. And that is pretty much it. I think you have enough information to try the next few examples. So you can pause this video, try those next 6, double check to see if you match. And I'll talk through my thought process a little more quickly as I work through those, and you can pick up where we left off in just a minute. So hit pause now and try those next 6. All right, unpause, here we go. 25 and 55, I know 5 goes into both of those. 10 does not, 50, nope, 25 doesn't. All right, 6 and 39. I know 9 plus 3 is 12, so I know that's a factor of, I know 6 goes into that as 6 goes in, I can't talk. 1, 2, 3, and 6 are factors of 6. Which of those go into 39? Does 6 go into 39? No, it doesn't, but 3 does. So 3 is the greatest common factor. You can check on your calculator, of course. 54 and 27. I know 9 goes into 27. Sometimes it's easier to start with a smaller number. 1, 3, 9, and 27. My gut reaction was 9, but I think 27 is actually going into both. So the largest one is 27. I almost got that one wrong. Now I got some with variables, 60 and 56. Those are 4 apart, so I wonder if 4 goes into both of them. Quick check, and yes, the 4 does go into both of them. They don't have any variables in common, so it's just 4. 30 and 20, I know 10 both goes into both of those. They both have a y. The smaller exponent is a 2, because that's essentially saying 10 goes into both of those, y squared goes into both of those. And then 4x and 12x, 4 goes into 4 and 12. They both have an x in common. 1 is the lowest exponent, so that is 3 through 8. And I wish you the best of luck in completing the rest of them, and come to class prepared with questions tomorrow.